Let's start now. Right. Okay, welcome to this course. This course is STF1153 Biostatistics. You guys are in biotech, right? Biotech field, first year.
Yes, Doctor.
So how is it going after a semester in this field, in this program? Is it good?
Surviving.
Very good.
Surviving. Okay. So
Still
you
good.
got more feeling on biotech now, I suppose. Okay, you're in second semester, right? Okay. So hopefully next semester you guys can enter the campus. I'm looking forward. We are looking forward to meeting you guys. Right. Okay. Anyway, so this course is STF1153 Biostatistics. It's a 3-credit course, right? So that's why you see the number 3 at the end of the code, right? So what this course is all about? This course focuses on. Okay, do you guys can see my elite screen over here?
Yes, Doctor. Keep calm and love
Yes.
biostatistics.
Yes, correct. Okay, thanks. Okay, so this is our elite. So everything about the lecture notes and also the recorded lecture I will post on elite activities as well. So just go on the synopsis. This course is about statistical methods. So you will be studying about statistics. Yeah. So how to use statistics in biotechnology, right? So you have to understand what are the tests, statistical tests, right, for analyzing and interpreting data. Okay. I'm from biotech program, so I would give some examples from biotech field. Okay. Right. So the assessments, we have 3 components. The first one is tutorials, which are to be done in a group. So the tutorials, they are all together, if I'm not mistaken, 3 tutorials. So you have to submit all, right? I mean, I will give the instruction for that later. So the tutorials carry 30%. Mid-semester exam carries 30%, and final exam carries 40%. Okay, so the marks before the final exam we normally term as carry marks. Yeah, so before the final exam, I will let you know what you got for your tutorials, what you got for the mid-sem exam. So so out of 60%, you will know what you get, so that you can have more ideas how to score for your final exam, perhaps. Yeah. Right. So apart from this elite, okay, I will also use Telegram channel. So please join. The link is here. You can just click here, yeah, right? And I will post quick updates on Telegram here. So Telegram is just for quick updates or bite-sized info, yeah? And also some polls. Maybe I want to ask you something that I can ask on Telegram. Okay. So right. Okay, let's move to, I'll go to the activity here later. So let's move to the introduction of the course. Oh, by the way, I haven't introduced myself. I'm Dr. Narashikin. I'm from Biotech program. Yeah, I teach biostatistics. You will meet me, some of you who will be in the second year. If you choose my class, I would also teach scientific communication. And in the third year, I would teach environmental biotechnology and bioprocess technology. Okay. My specialization is bioprocess fermentation technology. Right. Okay. Right, let's move to the slide that we have. So first, today we're going to, I'll brief on the course, what the course is all about, and then we'll move to the first topic, okay? Right. So the synopsis is on statistical methods. I've mentioned about it. Okay, so this is a calculation subject, right? So meaning to say that you have to do lots of exercises, yeah? So you have to deal a lot with the calculation, right? So what else? Okay, so the most important thing here is this course. Before this, it was there were 2 courses that you have to take, but now we have simplified it into one course. So this course will deals with what we call parametric and non-parametric data. So we're going to have a look at it later, right? So just to tell you that those are the two components of the course. Okay? So this course acquaints students with the assumptions required for the validity of the appropriate methods as well as their applications, identifies underlying principles for relevant statistical techniques, which can be built even by students in the design and implementation of their own research studies. Okay, the reason why we introduce this course is actually to help you guys to be skilled with tools and statistical tools, because apart from you are now in biotech field, apart from studying all the biotech courses, you have to know how to interpret or measure the results that you have later with statistical tools. Right? So actually statistics is a tool. So that's why you have to learn this course. And some of the topics might be a revision for you, because you might learn that before, perhaps in your school or in matriculation or STPM, but perhaps there will be some sort of new things that you also have to know. Yeah, so it's a combination of revision of and also new topics, perhaps. Okay. So at the end of the course, we expect you to be able to identify appropriate statistical methods, okay? Because there are many statistical tests which are designed for different conditions. So we expect you to know at the end which test to be used for analyzing this kind of data, and so on. Okay, so that's the first learning outcomes. And then you are expected also to analyze quantitative data using appropriate statistical tests, interpret and report the statistical results. Okay, that's the most important part. Because if when we deal with your data later on, you also have to interpret, report it. How are you going to present the results? How are you going to interpret it? So it needs some basics in statistics in order to interpret and analyze the data. Okay, so that's the course learning outcome. Okay, attendance. I think this is quite similar to other requirement or other courses. 80% is required, yeah, for you to sit for the exam. So if you can't, if let's say you can't attend the class, just let me know, okay, and make sure that you watch the recorded video, because I will record every lecture that I have, and I would post it on eLeap. Okay, and the lecture notes will be posted as well. So please make sure that you go through all those things. Yeah? I'm not going to be so strict with the attendance, because I also understand this is online is not really yeah, it might not be convenient to some. So please let me know. Just let me know if you are not able to attend or join the class, and make sure that you get the lecture notes. Okay. I think you have joined the eLeap. So there are three learning units for this course. Three topics, three main topics. The first one is Intro to Biostats, LU1. LU stands for Learning Unit. LU2, we are going to talk about non-parametric tests, data analysis of non-parametric tests. So under this, each of these LU, we have a number of lectures. Like LU2 have some, I think 3 to 4 or 5 lectures. Okay. So there are some subtopics under it, under non-parametric tests. And for the last topic is LU3, which is data analysis of parametric tests. And also we have several lectures under LU3. Okay? So this is just the main topics, the main learning units. Okay? So this is the breakdown of the learning units. Okay? We don't have class last week because some of you might not have registered, so we considered that. So we will cover what we're supposed to cover last week in this week. Yeah. So in this week, we're going to cover LU1, definition, concepts, and application, and also parametric versus non-parametric tests. And then next week, we're going to cover LU2. LU2 is quite long. It takes 1, 2, 3, 4, 5 weeks. Yeah. And then LU3, and then we have the mid-sem break. And then we have the mid-sem exam. Oh yeah, so the mid-sem exam will be informed later. Perhaps it's before the break, yeah, but the date will be informed later. Okay. Right. So after the mid-sem break, we resume with the LU3. LU3 has, yeah, 1, 2, 3, 4, 5, 6, 7, 7 lectures on LU3, 7 weeks. Then we have revision week and final exam at the end. Right. So I think this one I've mentioned about it. Okay. Any questions so far before we proceed with our lecture?
No.
No. Okay. Clear.
No.
Okay. Thanks. Okay. So we proceed with the first LU. So this is more to introduction. Some of it are just revision, yeah, to you. Right. So LU1 is about introduction to biostatistics, definition, concepts, and applications. Let's have a look at what we will cover in this in this lecture. So first, we're going to have a look at what is biostatistics. Before we proceed, you have to know what is biostatistics and why we study biostatistics, even though we are in biotechnology, right? So what is biostatistics? Why biostats matter? Some definitions and concepts. What are the types of data? The two components of statistics, measure of central tendency, measure of dispersion, and skewness. So those are the subtopics that we're going to discuss in this lecture. So biostatistics. So what is biostatistics? Basically, it's statistics, which is applied in biological field. Yeah? It's the application of statistical principles to questions and problems in aspects of medicine, public health, or biology. So that's why it's termed as biostatistics. Actually, it's actually statistics, but focuses on biofield. It's central to all of science because science needs that gathering of evidence and the evaluation of that evidence to make a judgment. Okay, so in science, it's not just about doing the science, whatever the science field we are in, like we are now in biotech. So it's not just about doing the biotech research, but at the end, we need to present the results. We need to report the results. And the way how we report and present the results, it needs analysis. It needs the statistical analysis because we are dealing with, apart from the qualitative data, we are dealing with the quantitative data. Quantitative data means something related to the figures. Yeah. So we need to convert whatsoever the raw data that we have to primary data or raw data to secondary data that gives meaning. Okay, I'll talk about it later. But basically, that is the importance of statistics in biological field or in biotech in specific. Okay. So why biostatistics matter? I think I have asked you guys in the elite, right? Let's move to the elite. Let's have a look at what you guys have shared on ellipse. So some of you have answered what biotech will be without statistics. So let's have a look at the answer. Can you see my screen? Elite screen?
Yes, Doctor.
Okay, thanks. Okay, there's so many answers. Thank you very much for your participation. Okay, now here, let's have a look at the answers here. What biotech will be without statistics? Cannot get accurate result in every experiment. Yes. Sampling process is not complete. The interest data is not organized. Did not achieve experimental design, especially in agriculture. Okay, so meaning to say that you want to say that. Is there any more? So it's important in the data analysis. In short, yeah. Okay. Okay, correct. Okay. What is statistics? Why there are so many? Okay. What is statistics? Is a study of methods to conduct proper planning, data recording, analyzing, data interpreting, data research. Yes, correct. With statistics, accurate data will be obtained. It leads to great discovery in biotech, data collection. Okay, yes, correct. Without statistics, it will be harder to conduct, could cause mess. Yes, correct. That's correct. I agree with that. Without proper methods, experiments are unlikely to fail. Yeah, correct. I like the word mess over there. Yeah, it will be a mess if we don't have proper statistical tools to analyze your results. Your data will be just there, you know. Yeah. Right. Role of statistics in biotech. Collect observation, present data precisely. Correct. Yeah, all are correct. Okay. Without statistics, unable to conduct analysis. Research purpose cannot be reached. Yes, correct. Yeah, agree with that. Because if let's say you have the raw data, but you don't analyze it, you don't actually see how your data, how your result can achieve or can fulfill your target's objective. So meaning to say that you do not know that your purpose is achieved or not. Yeah. Yeah. Yes, that's really true. That's correct. Okay. Thanks for that. What else? A measure, okay, without statistic inaccurate. Yes. Difficulties. Yeah. You will face difficulties. Right. Okay. What else? Without statistics. Data related remain just the data. Yes, that's very true. So when you collect the data, you don't analyze it. There are two things, two stages. You collect it, you do the experiment, you collect the data you observe, but after that you have to analyze. That is where the statistics come into play. Yeah. So without the statistical analysis, it will be just data. You do not know what happened to it, whether it's true or not. Yeah? So you need statistics to analyze it. Okay, what else? Roles of statistics in biotech: properly interpret results, correct. Correctly prepare experiment, yes. Verify the conclusions, yes. So once you know, let's say you determine the mean, the simplest one is the average values. So you can use it to represent your data. Use of statistics, DNA discovery, yeah. Business development, yes, correct. With statistic data analysis, can check the efficiency, yeah. Importance, planning and conducting experiment, correct. What else? Importance, analyze, okay. Without troubles with planning, yes. Support decision, yeah, it will support your decision. Yeah, that's why you here in statistics we will study about hypothesis, developing hypothesis, and we do certain sort of analysis, and then we relate back to the hypothesis, which hypothesis we have to accept. Okay. Interpret data analysis, draw conclusions. Yes. What else? Did I miss anything? Okay, so basically, yeah, all that you guys have written here are correct. Yeah? So biotech needs statistics. Without statistics, your data will be just data. There will be mess. Yeah, I like the word mess there. What? You can't interpret it. You can't get the conclusion. You can't know whether your objectives are fulfilled or not. Yeah. So basically, that's the main points. The why we need statistics. Okay. Thank you for your participation. I'll read it later, and I will perhaps give some feedbacks on it. Okay, let's go back to our lecture. Okay, back to our lecture. So why we need statistics? Because it provides tools and techniques. Yeah? It's not just for biotech, even other biofields like aquatic science, plant science, chemistry, zoology. We need statistics, huh? Not just biotech, but now because we are in biotech, so we will relate to biotech. Okay, for collecting data, summarizing, analyzing, and interpreting it. Yeah? So as I mentioned just now, when we do experiment, you collect the data. It's not yet over there. You have to analyze the data. What you meant by analyze is the simple thing is when you calculate, for example, the mean, the average. Yeah? When let's say you have replicates, you have raw data result for replicate 1, replicate 2, replicate 3. And at the end, when you analyze, what is meant by analyze is when you try to find what's the average values, what's the standard deviation, how to, how differ one data from another. That is through the statistical test, and we present it. So everything is under the statistical part. If samples of interest is representative to that population, that will provide good estimates regarding the population overall. Okay, now in statistics, we are also talking, we always talk about sample, we always talk about population, because whenever we do like experiments, we try to say that the results, you know what sample and populations are, right? I hope that you still remember those terms. Yes.
Sample is inside a population. Population is a number of beings in a certain area, is it?
Yes, correct. Correct. Thanks. That's a very correct explanation. Yeah. So and from now onwards, you have to get used to using the word sample and population, because we talk about it very much in this course. So when we talk about sample, so we want to actually use that results of samples to talk about the population. For example, if let's say you collect the microbes, for example, microbes or microorganism, bacteria, let's say E. coli from different states in Malaysia, right? Of course, you cannot cover every inch of the place in Malaysia, but you will select samples. You will develop the samples, and that samples is in terms of, let's say, states. There are how many states in Malaysia? 14 states, right? So let's say you collect, this is, let's say, a massive research. You collect the bacteria from every state. And even in every state, you have to cover all. You have to be not biased. You have to cover, let's say I talk about something smaller. Let's say in Sarawak, there are many divisions. So in order to, let's say Sarawak is the population, and under population, you have to set the samples, like in terms of the district, okay? And when you analyze the samples from all the samples, and at the end, you want to say that that sort of data represent the population, represent Sarawak. Let's say distribution of E. coli, something like distribution of what? Distribution of, yeah, let's say E. coli in Sarawak, for example, like that, okay? But you want, the way how you determine the samples and everything, it comes from smaller group, whereby later on you will conclude it to represent population. Okay? So that's what is here. So the analysis of the samples is important in order to make inferences or final conclusion about the population. I hope you get what I mean. Yeah? Okay, so that's the importance of biostatistics or statistics in biological field or in science in general. Okay. Right, let's go to the definitions and concepts. Some definitions and concepts. Okay, just now your friend have mentioned about population and sample. Okay, so he is right. Okay, population refers to the entire group of objects or people about which information is desired. Okay, so if I want to give an example just now, Sarawak, let's say you can define the population and samples by yourself, but you have to make it clear. Like let's say if I define Sarawak as the population, okay, the samples can be the districts, like maybe districts under districts in Sarawak, like Kuching, Kota Samarahan, Sibu, Miri, Bintulu. So those are the samples under the population of Sarawak. But if let's say I define my population as Malaysia, so my samples can be the states, something that is smaller than that. Sarawak, Selangor, Sabah, Kedah, Johor. So those are the samples if I define the population as Malaysia. Okay. So sample is defined as the part or subset of the population which is actually examined. Okay. So you have to define it according to your context, according to your studies. Okay, and then parameter. Parameter is also termed as variable of interest. So what is parameter? parameter is the thing that you investigate. Okay, for example, if let's say I want to look for maybe something simple, like something like number of hours adults students spend on internet. Okay, number of hours. Okay, let's say I want my population is, let's say, UNIMAS. Okay, now I define population as UNIMAS. So my samples now are students from different faculties, right? So let's say students from engineering, that's sample A, sample 1. Sample 2 is students from FEB, Faculty of Economy, and sample 3 is students from Faculty of Computer, something like that. So those are the samples. And I want to investigate, just now I said the number of hours the students spend on internet. Okay, I want to study that, right? So that is the parameter. That is the thing that I want to investigate. Okay, so that is called parameter. And it can be, it depends on your context, your studies. Yeah. And then we have data. What is data? Data is information, whatever the things that we, let's say the results obtained, yeah? The information, yeah? The data used in statistics, pieces of information. And then statistics. Statistics is defined as, let's say, a descriptive index or numerical summary. Normally we heard like the statistics of students, yeah, let's say statistics of what? Statistics of gender of students, like that, right? So it's like summary of the things, statistics. Okay, 40% are male, 60% are female. Okay? So it's a summary of something, statistics of something. So it can be statistics of anything. Okay, so at the end, the result of everything, the summary is called statistics. Okay, we use statistics from the samples we collect to try to make inference about population parameters. So I mentioned just now. So when we collect the samples like UNIMAS, I want to study about just now the number of hours spent by students from different faculties, which is actually samples, and the UNIMAS is the population. And at the end, I want to conclude on behalf of the population. Like, okay, in general, the students in UNIMAS, okay, spend about maybe 4 to 6 hours per day on internet, based on my observation on the samples that I carried out just now. Okay, so you can see that at the end we want to relate with the population, with the big picture of with the big picture, right? Based on the samples. Okay, so I hope that you see the association between samples and population. Okay, right. The types of data. Any questions so far? You clear about the samples and population?
Yes.
Yes.
Oh, clear, Doctor.
Okay, right. Right, now we move to the types of data. There are 2 types of data, quantitative data and qualitative data. Okay? So by the terms itself, you can see quantity. Quantity is like quantitative, something related to the number, numerical measurement. It has values. Okay. For example, something that has figures, the weight in kilogram, ages in years, prices in dollars, length, area, time, distance, temperature, bacterial count. Okay? So I think in microbiology you study about the bacterial count, blood pressure. Okay, and the figure, the data, it can be discrete or continuous. So there are 2 types of figures. This type of quantitative data, it can be discrete or continuous. So what is meant by discrete and what is meant by continuous? So let's say discrete. Discrete is something that is let's say I want to say in this class there are how many of you? 30? 20 female students and 10 males. So it's very clear that it's not 20.9 or 10.75. there's no such thing, right? When we count the number of males or females, right? There's no decimal points, you can say. So that kind of figures are called discrete data. Yeah? So let's say there are five red cars, 3 blue cars. So I don't say that there are 5.7 red cars or 3.9 blue cars. There's no such thing, right? So we go for the full number of that. So that is discrete. That kind of data is discrete. Okay. So some of the information here, if you see weight is not discrete. So continuous is something opposite to it. The easiest way for you to remember is continuous, that any figure that has decimal points. For example, weight. There are people who have weight of, let's say, 55.1, 55.2, 55.3, and so on, right? So it's continuous. There is no endpoint of it. So weight, length, they are continuous, right? Area as well. Distance, even temperature is also continuous. Yeah, there are 35.6, 35.7, 8, 9, so on. Bacteria count, okay, that one could be discrete, because when we count, we don't count half or 3/4 or 1/4. You count it as a whole number. Yeah? So discrete is a whole number. Person's blood pressure, it can be continuous because there are decimal points. Yeah. So for quantitative data, it can be divided into discrete and continuous. So make sure you know what is discrete, what is continuous. Okay. Qualitative data. Okay. So quantitative just how it relates to the figures. Qualitative data is something related to the attributes, to the features, the characteristics. Okay, if you want to say that there are, if you want to describe the color of hair of people, they are black, brown, blonde, right, white. So it's about attributes, features. Okay, so that one is qualitative data. And in biotech, let's say in microbiology, when you describe the morphology, the morphology, the feature of the cells that you observe under the microscope, like the bacteria, you can say that it's rod-shaped, it's spherical, it's what else? It's in clumps, something like that. You describe it, right? So that's an example of qualitative data. Okay, so it's something to do with the quality, the characteristics. Okay, examples is males, females. There are males, there are females. Political party area. And then t-shirt size, S, M, L. Something like attributes, the color, red, blue, yellow. Okay, so those are qualitative data. Okay, 2 components of statistical analysis. We have what we call descriptive statistics or exploratory data analysis. So what is descriptive statistics? It involves methods of organizing, picturing, summarizing information from a sample of population. So meaning to say that this is something very common to lots of experiments, whereby you do the experiment, you describe whatever the things that you observe, you describe whatever the things that you have collected, right? The data that you have. So it's about description. This it's related to the word description, describing the statistics based on the data that you have. 2 basic methods. Okay, this is how you present, how you analyze the data, right? Measure of central tendency. We're going to look at it after this. Measure of variation. If this is something to do with the analysis of the data that you have, okay? Like measure of central tendency, the easiest example is to find the average. Let's say you have many experiments, right? You do lots of replicates, and at the end you want to know what's the average value of the growth, and let's say whatever the things that you are measuring, right? So the average value will represent your data, isn't it? So that's what you do with your data. So that is the methods under descriptive statistics, okay? And you will present the data in the form of bar charts, plots, pie chart, histograms, graph. Yeah? So this is the way how you present the data. But the most important thing here is that you understand what is descriptive statistics. It's about describing whatever the things that you have or you analyze. Okay. The second type of statistics is inferential statistics. So what is inferential statistics? Inferential statistics is something to do with you make an estimation. Yeah. For example, in weather forecast, let's say we listen to the news, right? It is forecasted that tomorrow will be raining, it will be white. Okay, how they come up with that sort of estimation is because of they use the data, whatever, let's say, perhaps as the data for that month, or maybe I don't know how it works for the weather forecast, but they use whatever the data they have to estimate, to give something that will happen in the future. Yeah, so it's very contrast to descriptive statistics. Descriptive statistics is you just explain what it is at that time, at that particular time. But for the inferential statistics is you use the data to explain or to predict. It's something to do with the prediction, estimation. So it's very common in weather forecast, in stock exchange, the saham, saham, you know saham. So something to do with the forecasting kind of things. Yeah? So that is inferential statistics. Okay. Right. Example of applications. Okay. So descriptive statistics. Example of situation. A bowler wants to find his bowling average for the past 12 games. Okay. So he has played 12 games and he wants to find out what's the average score. Okay, so that at the end, the result will be in terms of the value of the average. So that is about the existing things. Okay, right. A politician wants to know the exact percentage of votes cast for her in the last election. Okay, so that's what happened in the past and what is, what the result is all about. And then Mary wants to describe the variation in her 5 tutorial marks in statistics course. And another example is Ali wants to determine the average weekly amount he spent on groceries during the past 3 months. So it's something to do with like the situation at that particular time or in the past. Okay, that's descriptive statistics. Okay, inference statistics, situation, a bowler wants to estimate his chance of winning an upcoming tournament based on his current season average and the averages of the competing scores. So you can see that he is using the data that we have now in order to predict what he will get in the future, to estimate the chance of winning. That is a prediction. A botanist wants to predict the rice yield for the coming year on the basis of growing trends over previous years. So it's a prediction for the yield for the coming years. And then the third example, Mary would like to predict the variation in her final statistics mark based on the variation in 5 statistics tutorial marks. So you can see the word prediction, estimate, yeah, that is inference statistics. Right. I think the last example is also estimation on the increase of the average income based on the past knowledge. Okay, so you can see the difference between the descriptive and inference statistics. Okay. So we move to the next subtopic. I hope that's clear so far. Right, we move to the next topic, measure of central tendency. This is just a revision for you, right? So under this central tendency, we talk about what is mean or what is average. Yeah. So how to calculate the average, median, and also mode. Yeah? So those are the 3 important parameters under measure of central tendency. Okay. So what is mean? You know, mean is average. You find the average, whatever the things that you have, we divide it by the number of things that you examine, right? So the formula is the population mean is denoted by mu. This is the symbol for average of population. Perhaps you need to take note on this. Sample mean is denoted by x bar. This is bar, x bar. Yeah? Yeah. So the formula is the same, but the symbol is different. Yeah? Because we normally talk about two things, sample and population. So the symbol is different, but the way how you find it is still the same. Okay. So this is just a symbol for the sample mean. Yeah? This one is sigma. This is a summation, right? So the total number. So whatever the things that you have, you total up. So that is meant by this sigma or summation, we call it. The sum. Okay. The n here is the number of data or observation, right? So if you're talking about the sample, you are considering all the observation in that particular sample. But if you are talking about the mean, the population, so you have to consider whatever the observation within that population. Yeah? So it's just that yeah, that's how it differs, the population. But you can say the formula is similar actually. And then mean for frequency data. Okay, mean for frequency data. This one is something to do with let's say you have a more complex data. Okay, like how to say, I don't have examples here. But frequency data. I don't have the example. I want to show the example. Okay. Like, okay. Do you mind if I take some time to find the examples? Hold on,
No problem, doctor.
Okay, thanks. If not, you will not get what is meant by that. Hold on. Yeah. This one. Okay. Okay, I think you can see this screen. Okay, let's say normal data. Again, simple data, you can see like this. Can you see the slide, the file that I shared here? Right.
It's visible, doctor. There's an ungroup frequency table with some numbers on it.
Yes, correct. Okay. So normally, if let's say you find the average, okay, so let's say this is the data given to you. So what is meant by frequency table just now is you are given this data, you construct a new data like this. A new table. like this one, this example. Okay, let's say you are given this example, this Jane Smith, Jane, Tom, Brian, okay, right? This is the raw data. So you come up with the frequency table. So what is meant by frequency table? You put it like into category. Like let's say Baka, there are two frequency, meaning that it occurs twice. So you put it 2 here. Brian, 0.5. Okay, so this is the frequency table. Okay, so I want to relate with the points just now. Let me see the frequency table just now here. The example is not that really specific. Let's see. Oh, okay, this one is much better. Okay, ignore the example just now. I think that is a bit different. Okay, this one. This is what I meant by frequency, meaning to say that the data exists in the form of table whereby there is a frequency. Frequency means how many it happened, right? For example, here, 0, this is like the number of school-age children. 0 for 0, there are 12 times. For 1, there are 6 times. So in order for you to find the average, right, how you find the average is you apply this formula just now. Okay, this is what actually this formula is all about. When you have the frequency, okay, I hope you got it. Later, if let's say you do the exercise, I'll give the exercise and you will see how you find the average for data with the frequency, okay? But basically, it's the same concept. Once you understand the concept of average, it's actually the same, actually, right? But it's just that we use the term F over there, yeah, to represent N, like this one. Okay, right? The mean for relative frequency distribution, the formula can also be used to provide an estimate of a set of group data. Okay, this one. Okay, what is meant by group data here? I'll give another example. What is meant by the group data? Okay, like this one. Okay, now, so if you see here the class, yeah, like from 2 to 21, 22 to 41, I mean, the category is based on this class and the frequency is 18, right? So this is what we call what do you call this one? Oh yeah, so this is what we call group data. Instead of, let's say, you just have like class 1, 2, 3, 4, but this one is from 2 to 21. So it's a group data. Between 2 to 21, there are 18 people. Yeah? So this is what is meant by group data. I mean, this one, this F up to F there, right? I just want to show you the group data, what is meant by here. Okay. The group data. Yeah. So the mean of group data. So how you calculate it? How do you calculate this? Sorry, it's not really organized in these lecture notes because this is the first time we merge the data, but the lecture is so This is not really advised by
It's
the
okay, doctor. Take your time.
coordinator. Uh, just refer to the old notes once and yeah. Sorry for that. I didn't realize that it's not that complete in that sense. Right. Okay, we are still in
It's okay,
mean.
doctor.
There are different types of mean. I'm trying to explain you different types of how you calculate the mean. Okay, so let's refer to this sort of data. Okay, measure of central tendency. So just now. Okay, the mean. Okay, let's say here. So okay. Well, I'll try to organize it later. Okay. I hope that you understand the mean. I'll explain in an example what is meant by these two things, frequency data and relative frequency data. Okay, but basically mean will be the same. You just divide it by the number of observations. Right. It's just that it's not complete. Okay. So we go to the median. Median is the middle value of the observation, right? So if let's say you organize it in, for example, the data in ascending order, right? First you have to order it, you have to arrange it in an ordered manner, right? And if the middle value is called median, okay? So if the number of the pieces or observation is odd, right? Is odd means if let's say it's a 7, 1, 3, 5, 7, 9, 11, okay? So it means that it is not equal. So you can easily find what's the middle point, right? So it's not really a problem. But if let's say the number of the data of observations is even, if let's say you have 6, right? So the middle value is, I mean, if you see that the middle value will be 3 and 4, right? So whatever the value at that third and fourth position, you have to find the summation and divide by 2. So that will give you the median value. Okay, so that's the difference between the odd number of observation and the even number of observation. Okay, so that's median. Right, mode is the value which occurs with the greatest frequency. Okay, for example, if you have, we don't have example here. If you have example of let's say, okay, give an example lah. Let's say, let's say, okay, let's say I give an example of this data. Okay, so these are all the data, right? So the one that occurs with the greatest frequency, for example here.
Excuse me, doctor. There is no slide.
Sorry. Oh, okay. Okay. So if you see here, what is the mode?
3.
3, yes. Yeah. So that is met by the one that occurs with the greatest frequency. Okay. Can you calculate the median in this example?
1 moment, please.
Yes. Yeah. Sure. So please get ready your calculator next to you every time for this course. Yeah. So we're going to calculate a lot just to keep you awake during the class. So how you to find the median?
Median is 3.
Okay, wait. I'm calculating first. So they are okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's odd observations, right?
Yes, doctor.
Yeah, correct. The median is 3. But the way how you determine that 3, you have to first arrange it in an ordered manner. Means that you have to arrange 2, 2, and then followed by 3, 3, 3. How many 3? How 1, 2, 3, 4, 5, 6, 7. 7 times 3, and then 6, 6, 7, and 9. Okay, so you arrange it first. So once you have arranged it, you determine the number of observation. In this case, there are 13, right? The number of 13 is odd. So you can easily get the middle value, which is the 7th position, right? 6, yeah. 6, 1, 2, 3, 4, 5, 6, 7, yeah. The 7th position. So that 7th position is 3. Yeah? So that's how we got 3. Yeah, that's how you find mode and median. Please remember for the median, the one is sometimes the one of the mistakes is students do not organize the number accordingly. Okay. All right, so that's mode. Okay, so this is just the summary, the mean, median, and mode. Yeah? And all of these are called the measure of central tendency, right? And the one that we normally calculate in anything is the median, the average. So that is the simplest statistics, actually. Yeah. Okay, and then apart from the measure of central tendency, we have measure of dispersion. So what is meant by dispersion is, when we talk about dispersion, the terms means how much it disperses. Okay, let's say we have 3 replicates. Okay, replicates. The reason why we do replicates is because we want to know how reliable the results is. But of course, we can't get the exact values for all the replicates. Let's say we are measuring what? Measuring, let's say, the bacterial counts. Okay, the bacterial counts maybe. So replicate 1, maybe for the first time we get maybe, let's say, 20. The second time we calculate, we got 25 or maybe 23. And then the third time we calculate as 24. Okay, so that shows the dispersion. When it means that it's not similar from one to another. So there is a dispersion. And how much is the dispersion? Dispersion, how much it is different, deviate from each other. But what is our standard is we have to calculate the mean, right? Let's say the count just now is like 23, 21, let's say 24, okay? The bacterial count. So we have 3 counts. The average will be let's say 40. What's the average for this? 23 plus 21 plus 24. Okay, let's say 68 divided by 3. The average will be 22.7, let's say. Yeah. Okay, so how we calculate the dispersion? We determine the difference between the mean and also each of the number just now. Let's say the first count just now is 23. So how much is the difference between the mean value and 23? Okay, let's say 21 is the second count. How much is the difference between 21 and the average value? Right. So that is this deviation. Yeah. And then the third count is 24. So how much is the difference between 24 and the average? So at the end, we total up the deviation. So that represents the standard deviation, the deviation of the data. Okay. Right. So one example is to some standard deviation, but apart from that, there are also other way of estimating the dispersion, which is range, variance, standard deviation, coefficient of variation, and also skewness. Okay, so those are under measure of dispersion. Okay, first let's have a look at the range. Range is the easiest one, but it doesn't actually give so much ideas about the data actually. Okay, let's say just now we measure the bacterial count and it ranged from 21, the lowest number of count, and the maximum number is 24. So the range is from 21 to 24. So you find the difference. 24 minus 21 is 4 minus 1, 3. So the range is 3. Okay, so that is what is meant by range. The difference between the largest and smallest measurement in the data set. Okay, so that's the term R, range. U is the largest measurement. L is the smallest measurement. Okay, the second parameter is variance. Is defined as the average of the squared deviation scores denoted by sigma squared. Okay, that symbol is sigma. This symbol is sigma, and the symbol for variance is sigma squared. Sigma squared. Right. Variance is a natural measure of spread provided by the sum of squares of the deviation from the mean. Right. Is the most commonly used measure of variability. It takes into account all the observation in a data. So there is a difference between just now range. You just measure about the highest and the lowest value, but this one is the average of the squared deviation scores. Okay, so the variance. So this is the formula of it, right? This sigma squared, 1 divided by n, number of observation, right? X is the value of each measurement, right? And this one is the the average value of the population, right? So the summation of this divided by the n. Okay, sample variance is denoted by sigma square. Right. Okay, so the formula is divided by n minus 1 for the sample variance is because it's actually to compensate, like, I mean, to make sure that the result is not how to say that over predicted. Okay, so that's why they call it they divide it by n minus 1. That is the rules of statistics, n minus 1 instead of the number of the n. So for the sample variance, for the population variance is divided by n. Okay. Okay, so sample variance, that's the formula, S square. This is the formula for the group frequency data, and this is for the relative frequency data. I'll give an example of group frequency data and relative frequency data on eLib or on Telegram. I don't have it in the same slide here. Okay, and then standard deviation. So standard deviation is related to S square just now because you just find the square root of it and you get the S, which is the standard deviation. So it's the positive square root of the variance. The population standard deviation is denoted by sigma alone. Because this one, if you find the square root of it, you get the sigma, right? And for that is for the population. For the sample, is the symbol is S. Okay. Coefficient of variation. So is the standard deviation is a measure of absolute variability in a data set. So what is the difference between standard deviation with coefficient of variation, right? So let's say the standard deviation is just measure about how much is the deviation, but this one is normalized by the mean, divided by the mean, and then multiplied by 100. Okay, so for example, let's go to the old slide. I'm sorry, this is the new slide. I do not know that it doesn't have the examples. We have examples here. Okay, I think I share this one. Okay, for example, coefficient of variation, let's say, this condition, let's say, is given for stock A, the mean is this, the standard deviation is this, stock B is this one, the standard deviation is this. Okay, so the standard deviation, you can see that the value is just a single value, but what it means. So it will be more meaningful if, let's say, we find the percentage. Like for example, when we find the CV for the first situation here, right, we divide the standard deviation 1.1 divided by the mean 3.2 multiplied by 100. So it gives 34%. So that 34% means that that is the amount of variability, amount of variation, 34% difference. So that is the coefficient of variation. So how it differs with the standard deviation. Standard deviation is just a number. It can be any number. But when we give the, when we normalize it over the mean value, it gives some sort of more meaningful number, like 34%. Now you know that, let's say the data is, the difference is about 34%, something like that. Okay, so that is the coefficient of variation, COP. Okay. Okay, so right, and the fourth one, the fourth way of measuring the dispersion is by the skewness. Okay, so what is skewness? It's a kind of measure that, sorry, I don't share it. Okay, skewness is a kind of measure that summarizes the extent to which the observations are symmetrically distributed. Okay, so if you have a data that is symmetrically distributed, is similar, is a bell shape or normal shape, so you would have this sort of data, right? Sorry, this sort of graph. Yeah? So we call it bell shape, and all the mean, median, and mode stays in the middle on the peak of it. Okay, so this is symmetric. But when the data is dispersed, right? Right, when there is a dispersion in the data, okay, it can be in two conditions, whether it's skewed to the left, where the mean is on the left than the peak. Okay, so that's why it says skewed to the left, or skewed to the right when the mean is on the right of the peak over here. So that defines how this one is skewed to the left and skewed to the right. It's based on the position of the mean. Okay, so this is the dispersion. This is how the dispersion is described. Okay. Right. So those are the four types of dispersion, measure of this five types of measure of dispersion: the range, variance, standard deviation, coefficient of variation, and skewness. Okay, and under measure of central tendency just now is there are three: mean, median, and mode. Okay. Right, so that covers the first lecture. Any question for the first lecture? Skewness is under this one. Yeah, so here we have covered what is biostatistics, why it's important, some definition and concepts, the types of data, quantitative, qualitative, two components of statistics, descriptive, inferential, measure of central tendency, mean, mode, median, and measure of dispersion. Skewness is under this actually. Measure of dispersion, the range, variance, standard deviation, coefficient of variation, and also skewness, dispersion. Okay. Do you need a break? Yes.
Never mind, carry on, Doctor.
Can we have a 5-minute break before we proceed with the second part? The second part is not that really much. It's just a few slides.
All right,
5 minutes
sure.
break?
I
Yeah.
have
Sure,
a
Doctor.
sure.
Yes, you have a question?
Yes, Doctor. So to settle this once and for all, 3 red-haired people is quantitative, right?
Sorry, say again. Say again.
3 red-haired people is quantitative.
Yeah.
3 red-haired people is quantitative, while red hair alone is qualitative.
Yes, correct. Yeah,
All right. Thank you, Doctor.
yes, correct.
Story of my life.
Yeah, thanks for highlighting that. Okay, whenever you want to present the result, just now I talked about quantitative and qualitative data. So when you are referring to the number of people, like just now your friend said that red-haired people, right? That is another type of data, which is the qualitative. But when we talk about the number of people having red hair, there are 3, right? That 3 is quantitative. Yes, correct. Thank you for highlighting that. So you
Thank
have
you,
to
Doctor.
see which point you are actually referring to. Yeah, which data you are referring to. Okay. We'll resume at 12:25. No, it's 12:25. I want to have 5-minute break because I have a class before this. I was a bit tired.
Right, sure.
Okay, thanks. Okay, so we resume our lecture. Okay, the second part is very simple. It's just a very introductory. So it's about the introduction to parametric and non-parametric tests or data. Okay. Right. So as I mentioned in the beginning, okay, this course we deal with non-parametric data and parametric data, and obviously non-parametric tests and parametric tests. Okay, so what's the difference between non-parametric and parametric data or statistics? Okay, so when we talk about non-parametric, there is less information. I mean, parametric is actually more structured, more organized in a way that it has the information about the population. Yeah, we talk about parametric first, and then based on the information, we have specific assumptions about the population. Okay, so hence we can make hypothesis, yeah, based on the parameters of the population distribution. So in contrast, non-parametric is something that is a bit arbitrary, something that is incomplete. Okay, like the information, the data is not that really, how to say that, the data is not that really complete. No information about the population is available. Maybe, or maybe it's lacking. Okay, so that is that kind of non-parametric data. And hence, because of there is no information, we can't make assumptions about the population. Okay, and also the hypothesis is free from parameters, so that's why it's non-parametric. It's not related to the parameters. Okay, so this is the continuation, right? For the parametric, it's based on the distribution. And parametric tests are applicable only for variables or parameters. Okay. In contrast, you can see non-parametric, the test statistics is arbitrary. It is applied for both variable and attributes. Variable is numbers. Variable attributes are characters or features, right? Variables are parameters. Right. Non-parametric tests exist for nominal and ordinal scale data, whereas parametric, there is no parametric test exists for nominal scale data. So what is meant by nominal is something like the quality. The nominal is something attributes. For example, if you talk about the color of hair, black, brown, red, white. Okay, that is nominal data. Example of nominal data. Okay, ordinal data is something in order. Like if let's say you see survey or satisfaction survey, for example, excellent, good, fair, average, weak, something like that, right? It's based on order. So that sort of ordinal data. So how we analyze that sort of data, we use non-parametric tests. Okay. So parametric test is powerful if it exists. It's not so powerful. So non-parametric data is not as, how to say that, it's not, is for data that is not complete, and perhaps the result of the non-parametric might not be as, what is meant by powerful here is might not be as conclusive as parametric. Okay, so that's what I can say in comparison. So these are the comparative tests. We are going to cover the test first and the parametric test. What are the tests needed, right? One sample, when we deal with one sample, and we deal with two samples for parametric test, and the name of it is here. And this is the equivalent, I can say, for one sample. For if let's say we are analyzing one sample data, for non-parametric tests, we are going to apply one sample sign test, right? So for the parametric test, we're going to use t-test and a z-test. I think you have covered about z distribution somewhere before, t as well as t distribution. Okay, for two sample data, this one is the test for the non-parametric. It will consist sign rank test. You just take note on the names. We will go in detail in the following LUs. So this is just a comparison, right? ANOVA is under parametric test. T-test is also under parametric test. Okay. So this is some comparisons. I think this one is also included just now. The parametric test makes certain assumption based on the population. So when parametric is no assumption, right? The possible assumption for the parametric test, the data shows a normal distribution, right? But for this one, because we do not know, we cannot, we do not know whether the data is, it shows normal or not. So no, there's no information. It can be normal, it can be not for non-parametric data. Okay, so I think this is the same sort of points with the slides before. Examples, the sign test, ANOVA. So the advantages of non-parametric tests, they are quite general, not difficult to apply, but the disadvantage is that, as I said just now, it might not be as conclusive as parametric tests because we don't have enough information about the population, but yet we carry out the test, and you know that that's why it's meant by powerful or not powerful just now. Okay, this is just to summarize the test that we will cover in the following LUs. We will cover parametric tests, one sample and then two samples and more than two samples for both conditions, parametric and non-parametric. Okay, let's have a look at one sample test. What is meant by one sample test? We are analyzing one sample compared to the population. Yeah, so that is meant by one sample test. Okay. So under a non-normal population, this one is under a non-parametric situation. We will apply sign test and will constant sign rank test. Normal population is for the parametric, is divided into when the variance is known and when the variance is unknown. Okay, this is Z test, T test. Okay, don't worry about this. We will cover this in detail later. This is just to give you an overview about what we will cover in the following LUs. Okay, two sample test means that we compare the two samples and we try to find the difference, right? And we relate with the population at the end. So that is basically what two sample test is all about, right? So again, it's divided into parametric and non-parametric. So if you can see for the non-normal here, this is non-parametric, right? And the types of two samples, it can be two types. It can be, the samples can be independent, means that the samples are not related to each other. This is meant by here, independent or unrelated samples. At or related samples, the samples are related to each other. Okay, so that's the types of the, when we deals with two data, okay? And here also you can see there are breakdown of normal population and non-normal population. Okay, don't worry about this, this is just the, you know, the summary. And also at the end, we will deal with when we have more than two samples, what kind of test that we are going to use. Okay, so under normal population, this is under parametric situation, and under non-normal population, this is under non-parametric situation. So this is actually the most common one that will be used basically in biotech, I would say. But of course, you have to know also situation for the non-parametric. Okay, three samples. So under this is ANOVA, and there are two types of ANOVA: one-way ANOVA, two-way ANOVA, and for this one is cross-covalence test and Friedman test. Okay. So there are many tests, and it has its own specific names. And what I can say at this point is that you will be introduced to all of these tests, and you will be introduced to what kind of situation or application that this test will be used. Okay, so in the exam, what happened will be that you will be given a data, and you have to interpret the data by yourself, whether you use non-parametric test or parametric test. Yeah? So that's yeah. So that's basically about the two tests. This is very short. Right, I'll go into detail when we talk about parametric. What is meant by parametric? I know that some of you might not be clear yet. Yeah, this is just the introductory. After this, we go in depth in each of these, parametric and non-parametric. What is meant by this nominal data and ordinal data? Yeah? So yeah. So basically, that's it for today's lecture. Yeah, we have covered LU1. LU1 is just introduction. Yeah, it's very basic. So it's introductory to all this. What is statistics? The central, just now in the first lecture, central measurement, right? And then dispersion, and then this one is just the introduction to non-parametric and parametric tests. Yeah. Okay. Any questions so far? Yeah, we're gonna finish our lectures here. Okay, I'll share back the attendance. I'll post the lecture notes and the recorded lecture on ELIP and also the tutorial one. And also the selection for the groups. Yeah? So because the tutorials are to be done in group. So I'll let you guys choose your group members. I'll put it the group selection on ELIP. Okay, any students who need manual attendance?
Excuse me, doctor.
Yes.
Will we be given formula sheets during the exam? I know this might sound redundant, but I mean, will the exam be like open book? Or not?
Yeah, it will be open book. I mean, but yeah, it will be open book. The formula will be given, but we will not tell the formula is for what, because like, for example, at the end, you will have lots of formula, especially for the different tests. So you have to know that this formula is what, this formula is what. Yeah, so it's given, but we will not tell it's for what. Yeah.
I see. Throwback to Form 5 SPM.
Oh, really? Oh, during your SPM, oh yeah, the formula is given, yes. Still remember. Okay, what is this group data? There's a question on the chat box. Okay, so if you have nothing to ask, then we can discuss here, right? Thank you very much for your attention. Sorry for the technical problems. I'll try to update the lecture notes with the examples that I promised just now, right? Yeah, so yeah, just keep updated on Telegram and on ELIP, okay? Right, so all the best. I'll see you guys in next week, and stay tuned to any updates that I post on Telegram and ELIP. Okay.
Thank you, doctor.
All right. Thank you,
Alright.
doctor.
Thank you very much. Yeah, welcome.
Thank you, doctor.
Thank you,
Okay, welcome. Have a nice day.